Hello everyone, welcome you all to the series of MATLAB tutorial. We started with an introduction to MATLAB, MATLAB programming basics, and so far we also have covered MATLAB data types. Once you understand MATLAB syntax, variable declaration, data types in MATLAB, then you can start doing operations on that variables. Today, I'm gonna cover MATLAB operators. We will begin by talking about the basic information about MATLAB operators. Again, we will go more little bit deeper in different operators available in the MATLAB for programming, like arithmetic operators, relational operators, and logical operators. Finally, I will talk about bitwise operations and set operations. As usual, for you to understand better, I want to keep this session mixed with theory part along with a live demonstration of a few examples. What is operators? An operator is a symbol that tells the compiler to perform specific mathematical or logical manipulations. MATLAB is designed to operate primarily on whole matrices and arrays. Therefore, operators in MATLAB work both on scalar and non-scalar data. MATLAB allows arithmetic operators, relational operators, logical operators, bitwise operations, set operations of elementary operations. MATLAB allows two different types of arithmetic operations: matrix arithmetic operations and array arithmetic operations. Matrix arithmetic operations are same as defined in linear algebra. Array operations are executed element by element, both on one-dimensional and multidimensional array. The matrix operators and array operators are differentiated by a period symbol. However, as the addition and subtraction operation is the same for matrices and arrays. And here are some arithmetic operators. After looking at a different arithmetic operator, let's have some hands-on session on arithmetic operators in MATLAB. Now this is the time to see the arithmetic operator examples in a MATLAB. To save your time, I already have created a script, and here I have added the MATLAB arithmetic operators and set some examples here. So we will go one by one and I will run them and show you the results. We'll start with the simple, that is addition and subtraction. Before that, as you know that this is a MATLAB and here is your current folder and here is your script where you have written the script to run your program. And today in this session, we are going to talk about the arithmetic operator. So here I have done some arithmetic operations on a different operators like addition, subtraction, multiplication, matrix product, and so on. This is a workspace, and here is the history window. So here in this first section, I gonna do the addition and subtraction. Simply what I have done, I use the one variable and the another variable. So a is a variable, here I am assigning the value 10, and b is a variable where I'm assigning the value 20. I want to do the addition, that is a plus b, and want to store that result in C. The same way I want to do the subtraction on a and b and want to store that result into the D. So in this section is just for addition and subtraction arithmetic operators. If I right click here, I can run this specific section, or even you can use Ctrl plus Enter command. Just you have to click and look for either that section is selected. This blue line shows that this section is selected. So I will just enter the command, that is Ctrl plus Enter, or right click and run the section. Once I run this section, you can see here a variable storing the value 10, b variable storing the value 20, c is a result, that is addition result, so I can see the 30 here, and d is a variable which store the result of subtraction, subtracting a from b, and that is a minus 10. This is a simple example where you just doing the addition subtraction. In the next level, if I scroll down here, I'm doing the multiplication and division. Now I use the same a and b as an input and calculating the results in E and F. So this section is already selected. Again, the same story. If I go and use the Control Enter, then this section will run. You see in E, the multiplication of A and B, that is 10 and 20 is multiplied, that is 200. And again, A divided by 2, that is half, that's 0.5 result is stored in the variable F. This is how we can do the multiplication and division. The next, here I wanted to show you the matrix multiplication, that is matrix product, and the array multiplication, that is element wise. What I have done, I have here created the matrix A and matrix B. If you want to create the matrix, just remember you need to use this symbol to separate in between the rows and column. If you don't use this symbol, then it gets created in form of array. So here I have created the matrix A is a 2 by 2 size, and B is a 2 by 2 size with the element 1, 2, 3, 4 and 5, 6, 7, 8. Now, if I want to do the multiplication, I can just use this multiplication symbol and the result should be this. So let's see this. Now I'm gonna run this section. I will use Control and Enter command. Now, here you can see the result. C is, if I double click on this result, you can easily see 9043 is in the first column and 2250 is in the second column. So this is the first row, this is the second row, this first column, and this is the second column. This is the result, and this is what we were expecting. We are expecting if the matrix A is defined this with these values and matrix B is defined with these values, and if we go for matrix product, the result should be the one which we have just seen here. So star is the symbol. With the help of that, we can do the matrix multiplication. And here I'm doing the array multiplication. So for the array multiplication, the another arithmetic operator I have used, and that is I use the dot and the product. What does it mean? It means I'm doing the element wise multiplication here. So the result should be this way. So if you see the D here, big D, and that is 5, 12, 21 and 32. So this is what the result which we were expecting. So far, multiplication, addition, subtraction, division, we have created the matrix multiplication in the, as well as the array multiplication with element wise operation. That also we have seen. Now let's go little bit higher, and that is matrix transpose and array transpose. Very simple. You can use this symbol from the keyword and you can do the transpose. Here is the A matrix, and you are transposing the matrix A to the variable called A transpose. What will happen? The arrays will get transferred to the rows and rows will get transferred to the arrays. So if I run this section again, control and enter, then I can get the results here. So if you see the A here, it was 1, 2, 3 and 4. Now it has been transferred to the 1, 3, 2 and 4. So 1, 2 was the first column. Now here, if I open this, 1, 2 is the result of the is a column, and earlier it was 1, 3. That means this 1, 2 is a transpose in the column that is 1, 2 in the result of A transpose variable. You can see here. So that way you can do the transpose. Very simple. This is operator. If you see here, this operator computes the transpose of the matrix. And the last, under this arithmetic operator, I wanted to show that the matrix power, this is a symbol can be used to do the matrix power, and for the array power we can use this dot, and then we can use this symbol for doing the array power. Example I have taken here is X as a matrix with the value of 2, 3, 4, 5, and what I'm doing here, I'm just taking the transpose, that is the square of that matrix, and here I'm getting the matrix square. The matrix name was X, so this is how I declare the variable called X squared, and here I will get the matrix power by 2. If I wanted by power by 3, I can do 3. If I want power by 4, I can do that by power 4. And in the same matrix, in the X, what I wanted to do, I wanted to do the element wise square. So here also I use very simple. For the element wise, you need to use the dot. Same story we have seen earlier here. If you want to do the element wise multiplication, we need to use the dot operator, and accordingly the transpose or the power or multiplication, whatever you want, you can do that. So this is the last section on this arithmetic operator. Now let's see, if I run this entire section with the control enter, then I can see the element square. So here earlier it was 2, 3, 4, 5 was the array where I did the square, and then what the result I got, that is a square of this matrix was 16, 21, 28, 31. And if I go for element wise, that means 2 raised to 2, 3 raised to 2, 4 raised to 2, and 5 raised to 2, then 4, then 9, 16, and 25. And that is the result I can see here. So these are the simple examples, but which covers most of the arithmetic operators which we have seen earlier in the table. And so very important is that MATLAB provides a variety of arithmetic operators for performing numeric computations. And we already have dived through the examples here. And remember that MATLAB evaluates expressions based on operator precedence. So use parentheses when necessary to ensure correct order of operations. The point is a relational operators. Relational operators compare the elements in two array and return logical true or false value to indicate where the relation holds. Relational operators can also work on both scalar and non-scalar data. Relational operators can be used in conjunction with the logical operators. It is used to create a test expression that controls program flow. In MATLAB, relational operators allows you to compare elements in array and return logical values in the form of true or false to indicate where the relation holds. Let's dive and see some relational operators. After looking at the list of the relational operators, let's dive into the MATLAB examples. Now this is a time to have some hands-on experience. So as I mentioned earlier, to save your time, I already created a M script where here I have written some script which operates on the different relational operators. So let's see that examples. So here is the script, and very simple examples I have created which creates or gives the idea how this relational operators works. The first relational operator is equality, and it is used by this symbol, that is a double equal symbol. So let's take example. Here I have created one matrix and another matrix is a B. So A and B are the two matrices, and what I'm gonna do here with the help of this equality relational operator, I wanted to check the result. So this is a one section and I wanted to run this section. So what I will do, I will use the control and enter key and I will see the result. So let's see how this relational operator works and what is the result we get under this variable result. So I just entered control and hit the enter button, and here I can see this is my one matrix, that is A, another matrix, that is a B, and here is my results. So if I open the result, here you can see the first row, second row, and third row. Again, it is a matrix, but everywhere we can see the zero. The second example I wanted to show you here is on the less than, greater than, less than or equal to, greater than or equal to. So very simple. I have created one series of number. It starts with the 1 and with the interval of 1. So this is a one series, and here what I am doing, I am just creating one matrix here, and then I'm checking the results. Is A is greater than or equal to B or not? So let's select this section. Here this section is selected. Just have to click here, and if I run this section, then I'll get the result here. So A, if you see here, A is a series also is created with 1, 2, 3. It's the interval of a 1. This is the symbol used and which automatically takes the increment of 1. So that's what it started with 1, then again 2 and 3, and this is how it is created here. And if I open this, this is a the one element I created and the another B is here. Okay, so if I go back to the script and look for the result, that is comparison result, here the comparison result variable I created, and if I hit this and check the result, here I get the result. So some places you can find the 1 and some places you can find the 0, and this is how this relational operator, that is here what we are checking greater than or equal to. So elements of the B we are checking with the elements of the A and wanted to compare that element wise, and here we got the result. And the last relational operator I wanted to showcase here is not equal to, and this is how it has been presented with the symbol not equal to. Here I have created one array and wanted to check the match is the results where I wanted to show the result, and here I'm doing checking with not equal to symbol, and the variable I used with a 4, so identify the elements not equal to. So this is how the script is written, and I wanted to run this section. So what I will do, I will just again enter control and hit the enter. So here is the result. Then let's look for the match. So here is the results. So 1 1 0 0 1 0 0, and if we look for the script also, we are comparing this 4 with the each element of this array and wanted to check where it is matching or not. So here not equal to. If I look for the results again back to the match, so here not equal to, that means yes, it's true, right? Here it's true. For the second place also it is true, because if I go back to the script, this 3 is not equal to 4. That means I will get the 1, yes. But 4 is not equal to 4, no, then the result I will get the 0. And that is what we are getting in a variable, resulted variable match. That's what we are getting the result. So very simple. You see the 1 1 0 0 0, and here it is matching. So if I look for the fifth place, that is this Again, it is not equal to 4. That means it's a true. So these are the very simple examples of the relational operator. We started with the equality, then we checked less than, greater than, equal to. Very simple. And finally, we also looked for the not equal. So that's all. Turn to see the logical operators. MATLAB presents Boolean data using logical data type. This type or this data type represent true and false states using the number 1 and 0 respectively. MATLAB offers two types of logical operators and functions. One of them is element-wise. That is, element-wise logical operator operates element by element on logical arrays and which uses the symbol and an ampersand approximate symbol to represent the logical array operators and, or, and not. And the second one is a short circuit logical operators that allows short circuiting on logical operations and that uses the ampersand symbols but in the double, and also these are the logical short circuit operators, that is the and or. Let's see some logical operations functions and their description. Now time to dive into logical operators in MATLAB. These operators are essential for making decisions, filtering data, and controlling program flow based on conditions. Let's go into the MATLAB and see the examples. Now time for the logical operators. And here is the examples which I already have created for you to save a time. We are starting with a simple example, and here what I'm gonna do is it's an element-wise logical operator. I used one variable where I assigned the value 5, then the another variable where I assigned the value 10. B is a variable and A is a variable. Now so far I have not covered if and else, but very simple. When I start writing the if we write this way, if and open the parenthesis and write the condition here, this is called uh, expression. We are checking the condition here and here is a statement. If this condition is true, then only this statement will get executed. Whatever the statement is written after the condition will only get triggered, only get executed if the condition is true. If the condition is false, it will not jump into this statement, it will jump for the next statement. And this is the normal syntax where you need to end the if statement. So here it started and here we ended here. Now this symbol, what I'm doing here, when I use this operator, logical operator, is called short circuit and operations. Okay, and as I said, this is entirely is an expression and this is a statement which we want to display. Now this symbol is an ampersand symbol, represent the logical AND operation. So here we are looking for the logical AND operations of 5 and 10, and we are displaying the condition is true or false. Same story I'm doing here. What I gonna do here, as I explained earlier, how if works. If start with the expression or the condition, here we write that, and here is the statement, and you need to close that. Here I have used the logical short circuit OR operator. This is a short circuit OR operator, and this single symbol is called a logical disjunction. So this represents short circuit logical OR operator. And here again with the same variable I want to check either they are conditionally true or not. And that's what I wanted to use the command display, and here I have written my string to display. So yes, this condition is also true. I have selected this. What I gonna do now, I will run this section and let's see the results. So if I run, what I will get? Yeah, both are true. So condition is also true. So that means this expression is also true, and this expression is also true. That's what we got the display for both statement. Condition is true as well as yes, this condition is also true. This is how you can use the element-wise logical operators. And I have covered the short circuit OR operator as well as the short circuit AND operator. The next logical operator I wanted to show is a relational operator, and which ideally returns the logical values. What I gonna directly use the number, okay, and I gonna use this command that is logical. 5 is less than 7, then I will get the answer, right? And another operator I used here is any, which tests along the first array dimension of the A, whose size does not equal 1, and determines if the element is non-zero or logical true. So here is the matrix I created, and here is I'm using that command, and here I'm getting the result. So let's test this section. So you can get the results here. So answer is true, yes, because 5 is less than 7. And answer for the B, if you check for logical correctness on that, is 0, 0, 1. And this is what we are expecting here. Very simple. And you can start using the logical operators for your application, for your programming, for your code. That's all under the logical operators. And here are the table which explains the different functions coming under the bitwise operations and their corresponding description. Now let's go to the MATLAB and see the examples, few of the functions from the bitwise operations, and let's see how it works. Here are some examples of how to use bitwise operators in MATLAB. I already created the script which covers the few of the bitwise operations. I'm starting with the best example, and the simplest example is a bitwise OR. I am using the variable A. What I'm going to do, this 10 value, I'm gonna convert that value with the help of this unsigned integer 8. Binary value is this for this 10. The same story for the B is a 3 I'm using. And here on this line, I'm doing the bitwise OR operations on A and B. If I look for the binary value for the 10 is 0, 0, 0, 0, 1, 0, 1, 0, and binary value for 3 is 0, 0, 0, 0 and 0, 0, 1, 1. And if I do the bitwise ORing for that, and this is what the result I'm expecting. So let's see how and what the value C displays us. So I'm gonna run this section, control enter, and here is the C. C is the 11, and this is what we are expecting, and here also it is displayed the 11 value for the C. The second I'm gonna present is a bitwise ANDing or operation here. Same value I use the 10 and the 3, and I'm doing the bitwise ANDing. So if I run this section with the help of control enter command, then I will get the C value as a 2. So you see here C is a 2. And if you want to display this value, we can display also. Let's use the display command and again use C. Okay. So this is the way of displaying the results in the command window. So here now, if I run this section again, save this, and with the help of control enter, then you can see this displayed the 2 as well. This is the bitwise and very simple. Third one is the bitwise OR operation. Same value I have used 10 and 3, and again I'm doing the bit XOR is a command, and where you want to do the bitwise XORing on the A and B, and this is how the syntax and the command written for the bitwise XOR operation, and here is the result. So if I want to again display this value, I will use the display, and this is the C, and again I will close this statement, and let me save this and again run the results. So let's run this results. So you will get the 9 as the result. So here you can get the result 9. Here also it will store in the C. So it's overwriting the variable C. Before reaching to the last section, bitwise NOT, how it has been done. Here is the value 6 is used, and bitwise bit comparison A is used. This is how you can do the bitwise NOT operation here. And if you look for the results, control enter, you can get C as a 249 here. Okay, so all bits are doing the NOT operation. So 0 is set 1, 1 is set 0, 1 is set 0, 0 is set 1, and if we convert that value, you can get this, that is 8-bit unsigned integer value, that is 249. And this is how the bitwise NOT operation works. And the last is a bitwise shift. So very simple. If you want to shift left, then we need to use the positive. If you want to shift right, then we need to use the negative symbol. If you want to shift by 2 position, then we need to use 2. If you want to shift by right side by 2 or 3 or 4, accordingly we need to use the negative and that value. Here I'm using the 6, and the bit shift is a command for which variable. For the A I want to shift, that means I want to shift 6 by left shift by position 1, and here the same variable 6, that is right shift by position 1, and this is how it is done, and here we will get the result. So if I run this section, control enter, then you will get the results. The C is a 12. Yes, it is a 12 I'm getting because we are shifting. If I shift this 0 this side, left side, then this 1 will get here, 1 will get here, and 0 will get, and additionally 1 0 will get added here. So this is how the result. And if we shift this value to the right side by 1 position, then you will get 0 added here, and here you will get this 1 at the LSB position. So, and if you calculate that value in unsigned integer, that's the 3, and that is what we are getting the result here. Very simple bitwise operations, and very important, these operations are efficient and directly supported by most CPUs, making them faster than performing equivalent arithmetic operations. These examples demonstrate how to use bitwise operators to manipulate the bits of numbers in a MATLAB. Now, it's up to you now how effectively you can use the bitwise operations for your personal application, for your programming, and for your coding. It's a set operations. Set operations compare the element in two sets to find commonalities or differences. In MATLAB, the sets are arrays of numbers, dates, times, or text data. Most set operations compares sets for exact equality, which can be problematic in context of floating point arithmetic. For that reason, the isMember TOL and unique TOL functions are also available to perform comparison with a tolerance. MATLAB provides various functions for set operations like union, intersection, and testing for set membership, etc. Now time to go to MATLAB and see the examples around the set operations. So we have seen the table of set operations. Now here are some examples of set operations in MATLAB. I already have created the script and few of the set operation examples to save your time. Let's start with few of them. The first operator is an intersect operator. And what it does actually, it finds the common element between the two sets. Now I have taken one array and the another array as a set. What is the value inside this A is 1, 2, 3, 4 and under the value is a 3, 4, 5, 6. If I check for the intersects between A and B and if I use this command intersect A and comma B and if I assign that value into C, that means intersection is a 3 and 4 is a common element between the two sets. So let's run this section, control and enter, and you see the result C is a 3, 4. That means it is finding the common element between a set A and set B, and the common element is a 3, 4. Very simple. Another example is a union. Union is another set operator, and how it works, it finds and also it combines the elements of two sets and removing the duplicates as well. If I have a set of this set of element is A is 1, 2, 3, 4, and here what I am going to do the same, that is 3, 4, 5, 6. What is common, that is 3 and 4 is a common, and I want the union for that. So I use the command union, then A set, B set, comma A comma B, that's A comma B, and if I assign that value to D, what will happen? It will combine the two elements and as well as it will remove the duplicate. So duplication is 3, 4, right? Which has been extracted with the help of this intersect command. And here I will remove that and I will just combine the elements of the two sets. So if I run this section, then let me if I run this section, then you can see that D will be 1, 2, 3, 4, 5, 6. That means it has combined 1, 2, 3, 4 and 5, 6, and it as 3, 4 are common, it removed that duplicate elements as well. So very simple. The next one is I wanted to show you is the set difference. If we use this set difference, what happens actually, it finds the elements that are in the one set but not in the other set. And the tricky way is used to this command is try to understand when I said write set difference A and B, that means it finds the element from the A set A which is not present in the set B. That means 1, 2, 3, 4 is a reference, and I wanted to check out of this 1, 2, 3, 4 which is not present in the element B. So the answer is 1 and 2 is not present. If I run this, control and enter, then you can see E is 1, 2. But if I revert this, if I say B and if I say A, that means set difference from the set B to the set A. That means 3, 4, 5, 6 we are checking whatever is not present or is not in the other. That means 3 and 4 is not. So if I run this, control and enter, then you see E is 5, 6, right? Because 5 and 6 is not present in this A, right? So earlier the 1, 2 was not present in this, and now the 5, 6 is not present in this. This is how the way you can use this, and that syntax is very important. Which set of element you are considering to look for elements from the other set. I think you are clear after using this set difference operator. And the next one is set exclusive OR. Syntax for that is set XOR. Here I have used the same set also A and the same set for B, what this command usually do? This command finds the element that are either of the set but not in the other set, right? So 1, 2, 3, 4, 5, 6. So 3 and 4 are common. So it will skip that and it will find only 1, 2 and 5, 6. So it is finding the element that are either of the sets, right? So if I run this, control and enter, then you can find the F is 1, 2, 5, 6, right? 1, 2 and 5, 6 because 3 and 4 are present in the A and B. Very simple. And the last I wanted to cover under the set operator is unique. I have created one set here 1, 2, 2, 3, 4, 4 and 5. Deliberately I duplicated few of the element that is 2 and 4. But I want to find the unique element in this array. And if I use this command unique A, then I can find the only unique elements from this set. And that are 1, 2, 3, 4, 5. So it will avoid the duplicated elements. If I enter, control enter, run this section and G will be 1, 2, 3, 4, 5, 6. You can see here 1, 2, 3, 4, 5. So here is the answer. G will be 1, 2, 3, 4, 5, 6. It has find the unique between this set that the element unique elements from this set A and the unique is A, that's 1, 2, 3, 4 and 5. It removed a duplication. This is how the way you can use this set elements, very simple. And these functions are very useful for handling and analyzing the data sets in the MATLAB. And these are the few examples for these set operations which are taken from the table which I just presented earlier. So now up to you how you can use the set operations in your program as well as in your code. That's all under the set operations. Watching this video, I'm sure that you understood MATLAB operators. What is arithmetic, relational, logical, bitwise and set operations in MATLAB? If you really like this session, then please give this video a thumbs up. To watch more videos like this, please consider subscribing. Once you hit the subscribe button, you're gonna get the notification anytime new contents like that comes out. And lastly, if you have any queries on this topic, you wanna answer me, leave me a comments below. I read them all. That's all I have for you today. Hope you enjoyed and hope to see you next time. Bye bye.